Hello and welcome to Geometry, Law of Cosines. In this video, we're going to solve problems using the law of cosines, where if we're given three sides of a triangle, we're going to use the law of cosines to find the included angle. And then if we are given two sides of a triangle and the included angle, we can find that third side. And then we're also going to talk about how we can use the law of cosines as a starting point to solve for the rest of the triangle using the law of sines. Here are some of the standards that we are going to touch in today's video, and these are from the Florida's Best Standards for Mathematics. So let's go ahead and get started. So here is our formula for the law of cosines. It looks a little like the Pythagorean theorem, but then it starts changing up towards the end. And so we've got c squared equals a squared plus b squared minus 2 times ab times the cosine of c. And so with this, when we have our included angle, that is going to represent C. And so this is our included angle. And so very similar to the area formula that we used before with sine, where we were dealing with that included angle being C, it's the same for the law of cosines. So don't get mixed up by these letters here. If you need to take them off, then take them off. As we know, there are times where they're giving us a formula, but it doesn't necessarily match up with the variables being used in our diagrams. So just kind of keep that in mind. So C is going to be that included angle. And so when we go to build this out, this becomes A and B, forming that included angle. And then C is going to be across from that. And so now let's build out our formula. So C squared is going to be x squared equals A, which is now 7 squared plus 3 squared, so the two sides that form that included angle, minus 2 times those two sides, so times 7 and 3, and then cosine, and then our included angle, which is 41. And so now from here, we can simplify some of this just to kind of get it out of the way. So 7 squared plus 3 squared is going to give me 58. 49 plus 9 gives me 48. And then minus, and then 2 times 7 times 3. So 7 times 3 is 21. Times 2 gives me 42. And then cosine 41. So now this looks a little bit easier to deal with. And so now from here, I can go ahead and type that into my calculator. And so I have 58 minus 42 times, and then make sure you put that 41 first, then hit your cosine button, and then don't forget to hit that equals. And so we've got what's on this side of our equal sign, but we know to get x squared by itself, we need to take the square root. So I'm going to go ahead and do that now. So I'm going to hit this square root button here, and that gives me 5.1. And so x is going to equal 5.1. So don't forget that we took the square root of both sides. On that handheld calculator, when we're typing, we put that square root at the very end. If you are using your on-screen Desmos calculator, it's a lot easier to just type this whole thing at the same time. And so this is how we would solve for x. And so we get 5.1. We're just using our formula. The big thing about this is just knowing that C is your included angle, and then going from there. All right, so let's do another one. Remember, C is our included angle. And so the included angle here is now X. And so these two sides become A and B. And so C is going to be that third side. And so now our third side C here, and then we can go ahead and label this as A and B, a little contradictory to what we did before. And so now we've got 22 squared equals 16 squared plus 20 squared minus, and then 2 times those two sides, and then cosine of our included angle, which is now X. And so now let's start typing some of this into our calculator and going from there. So I've got 22 squared is going to give me 484. And then we've got 16 squared is going to give me 256. And then 20 squared is going to give me 400. And so I can start cleaning some of this up and simplifying some of these squares out. And so this is going to give me 656 minus, and then 2 times 16 times 20. And then we know that 16 times 20 is going to be 320 times 2 is going to be 640. And then our cosine of X. And so now to start to try to get X by itself, we can go ahead and get rid of some of this. And so I'm going to subtract 656. And I get negative 172 equals negative 640 times the cosine of X. Then I'm going to divide by negative 640. Don't worry about these negatives yet because we're going to end up getting rid of them, so don't worry. And then from here, I know that this is going to get rid of this, but I still have that cosine in front of X. And to get rid of that cosine in front of X, I'm going to need to do the inverse cosine. And so I know that I would need to do the inverse cosine on both sides. And so X is going to be the inverse of cosine times negative 172 and negative 640, there, like that. And then let's go ahead and put this into our calculator. So make sure it's all cleared out and ready to go. And so remember, we put our numbers in first. So we have 172, and then we make it negative, divided by 640, and then we make that negative. Then we can press equals. And then to do our inverse, we're going to do second cosine, and that's going to give us 74.4. And looking at this, I'm just going to go ahead and round it down to 74 degrees. And so that's how we would find X from here. All right. And then let's go ahead and take a look at another one. So same thing goes with this one. This is going to be our included angle, so that's going to be this. C is going to be across from here, and then these two become A and B. So it can be a little bit tricky just because with the law of sines, we were doing a lot of angle A is across from side A, angle B is across from side B. But with this, you have to be a little bit more intentional about what you're putting with what. So it kind of can be a little confusing. All right, so with this one, we've got c squared equals, and then we have our two sides, 4 squared plus 5 squared minus 2 times those two sides, and then cosine of our included angle. So now I'm going to get out my calculator, and I can actually put this entire thing into my calculator. I don't have any x's on this side, so there's nothing to kind of get by itself, so I can type this whole thing in. I just need to be careful. All right, so I've got 4 squared plus 5 squared minus 2 times 4 times 5 times, now make sure you put 85 first, and then hit your cosine, and then make sure you hit equals. So c squared is equal to 37.5. And then remember, we're taking the square root of that. So now I'm going to hit square root, and I get 6.1. And so here I'm going to get 6.1 because I went ahead and took the square root of this entire thing. And so I was able to find this side to be 6.1. Now from here, if I wanted to figure out what my other angles are, I can now use the law of sines. And so now I would have the sine of 85 over its opposite side is equal to the sine of angle A over its opposite side over the sine of C and its opposite side. And so I would able to use these proportions to cross multiply, find out what that angle is, and then once I find out my second angle, I already know how to find my third angle. And so if on your EOC, they might ask you a question about, okay, how would you set up the proportion for the sines, or what expression represents this particular triangle? And so in that instance, we would have something where they might ask us to identify this entire thing, but we had to use the law of cosines to find this first, to be able to figure out that that was 6.1, something like that. And so on your EOC for the law of sines and the law of cosines, usually they're going to give you these formulas inside the question. So they're not going to be on your reference sheet, but these are probably formulas that you're not going to be required to remember. So they'll probably give you the law of sines or the law of cosines formulas inside the problem. All right, let's do one more. And so with this one, we could go either way with this one. So we can choose any one of these angles as our included angle. I'm just going to choose angle A. So for this one, it doesn't matter which one you choose, as long as you're setting it up correctly. So remember, angle A is being formed by 8 and 20. So if we choose angle A, we need to make sure that we're using 8 and 20 as A and B in our formula. All right, and so for this one, its opposite side is 14. So now we're going to have 14 squared equals 8 squared plus 20 squared minus 2 times those two sides, and then cosine of that included angle, which is actually angle A, and we're just going to label that as X. So we can label this as X. And then from here, we're just going to go ahead and solve. So for this one, we're going to, and you could could type this whole thing into the calculator and do it a lot faster, but we're just going to take it step by step. And so let's go ahead and get some of this narrowed down. So I got 14 squared is 196, and then 8 squared, which is 64, plus 20 squared, which is 400, gave me 464, and then minus 2 times that 8 times 20. We know 8 times 20 is 160, so times 2 is going to be 320. And then I subtracted 464 from both sides, and so this is what I ended up with. And so now from here, to get cosine x by itself, I'm going to divide both sides by negative 320. And then I know that this is going to get rid of this, but to get rid of that cosine, I need to do the inverse. And so this is what I want to type into my calculator. And so now I'm going to, we have 268 negative divided by 320 negative. And then from here I'm going to press equals just so I can get this entire fraction narrowed down into my calculator. And then I'm going to do second cosine, and that gives me 33.1, so I'm just going to round that to 33 degrees. And now that I know that this one is 33 degrees, I can put 33 here. And then from here, I could use my law of sines again to figure out my other two angles from here a lot faster than doing the law of cosines again. So doing the law of cosines, it's a pretty long formula. It's not a hard formula, it's just a lot kind of involved. Where the law of sines, you're setting up your proportion and it seems a lot faster. And so from here, I would say the sine of 33 over 14 is equal to the sine of angle C, which is this one right here, over 8, and then I have the sine of B, and I'm just going to move this all down here. Is over the sine B is over 20. And so from here, I would be able to use my law of sines to be able to go from here. So the law of cosines is a good starting point or a jumping off point for the sines. But remember, on your EOC, they might ask you questions about what expressions represent the triangle. And so you just have to kind of be careful that it's not always about finding the answer. Sometimes it is more about the process. And that concludes our video about the law of cosines.